So, cognitive load theory is one of the most important theories you can actually use to make yourself a better teacher and lecturer, especially in the technical and vocational and occupational space. So, let's take a look at what it is and let's read the definition. I'm going to do it in red and you'll see why. It says that it's an educational theory that provides instructional principles, that's good for us, informed, and this is why I'm doing it in red, by the limits of human working memory. So it's a theory that's based on limitations, because with limitations come opportunities, right? So in order to understand that, we've got to take a look at three different things: sensory memory, working memory, and long-term memory. Now, the key thing when we start off with sensory memory, you kind of know what it is, and I'll do another video on it, is that's really things like our eyes, which see, our ears, which hear, and our hands and our bodies, which touch and balance and make sense of the world. Now, these are key things which we've got to work with. Now, look at this. It's theoretically unlimited. We can get so much stuff coming through, and it streams in from all these zones. And the more we do it, the richer it gets. You can see it streaming in. But when it hits working memory, the present space we're working within, it's got a marked limited capacity. And the way they say it, it can hold basically 5 to 7 elements, like a phone number, or if you're working with them together, like you're trying to work out how they combine, then what happens is you can only work with 3 or 4. But the key point is that it's markedly limited, right? From the stream of stuff coming in from your sensory zones, it's got to work in this present working memory, which is limited, and paying attention to it. And then you can get it into this theoretically unlimited long-term storage, long-term information. And as you know, you can remember lots and lots of things. So you can see there it's going out again and it's getting huge, right? Now, the way you get it into long-term memory, you can see, and I'm going to highlight it, they've got this over here. It goes both ways. The best thing that you can do when you do this kind of thing is, and I'm going to do it in blue, is what happens is when it gets into long-term memory, the best thing to do is to take it back and get it into working memory again, and then through across. And that's the way you get it into long-term memory, right? But now the next key thing you've got to note about it is they say that it holds, and I'm going to do it in blue again, it holds cognitive schemas that vary in degree of complexity and extent of automation. Those are two key terms, right? Now, a schema is a highly organized combination of ideas, right? It's like your maths and your biology and your history. It's kind of structured knowledge. It's not point by point by point, right? It's more a situation where you've got something, it's organized with something else, and that then builds, and you've got something working with it, and you link it, and all of these things working like that start to work together when you get it as one thing. So instead of having 1, 2, 3, 4, 5, 6 things, when you get this organized, it's actually just working as one thing, right? And the more you practice it, the more it results in automation, the easier it is to use. Now that's fantastic, because what that then means is you're in a situation where it's automated, where instead of just holding, you see here, it says, I'm going to highlight it in blue, it says it can hold 5 to 7 elements. Now, instead of those 5 to 7 elements just being a situation where it's like this, and like this, and like this, 7 elements like that, instead, one of the elements is this size over here. So you've got 1, 2, 3, 4, 5, and these are structured, so you can work with it. And that's the baseline of understanding how cognitive load theory works. It's trying to get you to do things where you ensure that more and more structured information gets used in your working memory.